Awesome. Okay, welcome everyone. As you join us, please post your name and state in the chat. We are so excited that you are here with us today. Welcome to the All Learners Network Annual Conference 2021. We'd love to know which state you are coming from. This event is sponsored by the Vermont Agency of Education. We're really appreciative that they sponsor this event for us so that it is free for participants.
So if you're here for the first time joining us, we're so excited to have you all as part of our conference. We are doing a special kind of promotion on our social media. So we have accounts for Facebook, for Twitter, for Instagram, and for TikTok. I just learned the other day TikTok is going to take all of them over. So if you're not on TikTok, you might want to consider getting on TikTok. We are giving away 4 $25 gift cards, and you do have to do a little work to get that. So you will need to, on one of those platforms, you'll have to follow our account. You'll have to like the post that looks like that image on the left. On Twitter, it is pinned at the top, so it'll be the first tweet you see on our account. And then you need to comment on that post and tag 3 of your friends. We do have one more day of our conference, which is December 8th. So you can still sign up, or friends can. And on December 10th, we will be choosing our 4 winners, 1 from each of our platforms. So the more of those platforms you join and comment and post and like, the more opportunities you have to win. Also, one other last thing, we are using the hashtag ALNCon2021 for any tweets or any social media posts that you make to connect the conference tweets.
All right, so tonight we have a very special guest. Steve Leinwand is here to do our keynote address titled Some Practical Strategies for Effectively Differentiating Instruction in Our Math Classrooms. And then we have a variety of other offerings for you tonight. There is some work with, but it really is a diverse list. So hopefully you see something up there that interests you. So I am going to introduce Steve. Steve Leinwand is a principal research analyst at AIR and has over 35 years of leadership positions in mathematics education. He currently serves as mathematics expert on a wide range of AIR projects that turn around schools, improve adult education, evaluate programs, develop assessments, and provide technical assistance. He has family connections here in Vermont, so we feel like he has a little bit of Vermonter in him, and we're really, really excited that he's joining us for the All Learners Network Conference. So whenever you are ready, Steve, you can share your screen, or TJ, is it easiest if you share from yours? What do you think?
No, it's easier for me.
Steve, thank you.
Until you stop, there it is. Okay, so now that ought to work. And then I can come over here and I can click on this baby and then on this baby. Look at that. And then I can do, where is it? Right there. Look at that. And I can share that. And then I can full screen and magic. Look at that. So I can move this over and there it is. So we have what is a perfect mini keynote. Let's go back. Okay, there's my email address, easy. There's my website, easy. And yes, I mean, when you have 25 minutes, it's a mini keynote. And so I get to just set the stage for all of the amazing things that come the rest of this evening. There it is. I ask you to stipulate what you know, right? They're different. If they're different, meaning our students, then I think you all know that it's almost stupid to have to say it, right? But all effective instruction differentiates or accommodates those differences, or it's not effective. And so that's really easy to say. And we hear differentiate, differentiate, differentiate. And the problem is that far too few people really know what it means, because it's one of these terms that just gets bandied around. So let's be more specific. Right? Let's stipulate too that in every class of say 20 students with obviously 20 diverse brains, they are processing the math in 4 or 5 different ways. You all know that. And they're seeing the math in 4 or 5 different ways. And so if we just sit there and go, but of course, that's why the one size doesn't fit all. Why the one right way to get the one right answer is simply not effective teaching. It doesn't make any sense. And so, ergo, to launch this discussion, I think that the heart of differentiation is instruction. It's alternative approaches and it's multiple representations. And how do you get at multiple representations and alternative approaches? What I tell principals is the single most important question that they can ask, that they can listen to. I tell this to coaches. When you wander in the classroom and the 72, and all the kids have 72, and you move on to the next question, you've missed that opportunity to say, really? Why? How do you know? That's what we mean by less is more, and that's how we begin this process of differentiating. And when the kids start to talk about, how they got 72, the obvious question is, so who did it differently? Who did it differently than that? Yesterday, a different class got it in 5 different ways. I wonder if we could find 6 different ways. Good. Maxine, how did you draw it? Right? Sarah, how did you picture it? Who pictured it differently? Show me on your whiteboards. And so today really is about, what does that mean? What does it mean when we are forever bombarding kids with, that's cool, who did it differently? That's cool, who drew it or pictured it differently? Can you show us? And so what might that look like? There you go. Typically, just think about how much pain there is in the world because of sign numbers. Just stop and think about how much time and effort goes into, all right, let's go. Number 7 of 12 mindless exercises to get the sums and differences of sign numbers. 5 plus -9. Answer, scream it out. Wonderful. So we don't need to go to the chat room. You don't need to unmute yourself. You just need to sit there and think about what that could have been. And then I say, oh, cool. Who got an answer other than -4? Who got an answer other than -4? Oh, nice. And so we write all of them down. And we sit there and say, could they all be right? Could +4 be right and -4 be right? I don't think so. Well, why not? Well, which one is right? Neat. How did you get it? And all I want to do is I want to remind you about what we do to kids' brains. I can't tell you how many classes I'm in where I hear, well, obviously, to find the difference of 2 integers straight out of the textbook, straight out of the way to do it, subtract the absolute value. What the hell does absolute value have to do with adding and subtracting sign numbers? And then assign a sign. Don't you love that? Don't you love having kids? Well, I need to assign the sign of the integer and you know that you have just stopped brains. You know that you have just lost kids. You know that there is no differentiation going on here. This is the one cockamamie stupid ass rule that no normal human being ever uses. Oh, sure, it works all the time, but it has nothing to do with building mathematical understanding. And so just look when I say, now find the answer in a different way, in another way. And I think that you all know that we empower our students when they are able to sit there and go, oh, that's easy. I just think about money. I have $5. I lost $9. Well, I lost 5 to get back to 0, and there's 4 more to lose. That's great. For some kids, it sucks for other kids. You know how many, particularly in this sexist world, how many boys with their football brains sit there and realize that when Tom Brady gains 5 yards, it doesn't make any difference. He's gone down to Tampa Bay. They still love him, right? When Tom Brady gained 5 yards and then he lost 9, oh, well, sure, he's 4 yards beyond scrimmage. Really? You all know that the reason why we're doing this notion of alternative approaches and multiple representations is every one of you who has taught sign numbers to 6th, 7th, 8th, 9th, or 10th graders knows that there are 3 out of 100 kids, sometimes 4 out of 100 kids, who sit there and go, I don't get that horizontal number line. It doesn't make any sense that you go up 5 and then lose 9. Those kids, for reasons that are totally unclear to me, have to deal with 5 degrees above zero on a thermometer. And then they all sit there and say, oh, sure. And then you get 9 degrees colder. You go through zero, you got 5 more, and then it's 4 more than that. Oh, how nice. And so we know that the vertical number line is a critical representation for some kids. We know that why is it? We do all this decomposition with whole numbers, and we're going to see that in a second. But we forget that this thing is 5 plus, well, -5 and -4. Oh, nice. And that's the perfect into the zero pairs, and using the red and the black color cubes or the different markers or the zero pairs and all that stuff that works out. I mean, it's so obvious that there are 4 negatives left over, right? On the number line, you start at 5, you move 9 to the left. I'm sorry, that's my brain. Oh, great. I'm so smart. I can do everything on a number line. And then I have to stop and realize my number line is utterly useless to probably half of my students. And so, but this is the way you have to think about it. And I'm realizing that I'm talking to Mars as Venus and Venus as Mars. And then back at this idea of vertical as opposed to horizontal, these are the kids that need sea level and elevators. And then I can do checks and bills instead of have and lost. The point being that look at how this notion of how did you do it? How did you do it? Did anyone do it this way? And we build a repertoire, and then we say, which way works for your brain? Which 2 ways work for your brain? Now, apply that to -7, -8. Oh, wait, no rules. Stop, see it, picture it. I lost 7, I lost another 8. Where am I? What does that mean? How nice. And so typically, right, we do the whole beginning of this with 8 plus 9. And the answer is 17. Aren't you happy? Right? And so we expect that every single kid is going to sit there and go, 8 plus 9 is 17. Great. Bing, bang, done. Are you happy? Except for all the kids that are still struggling with their fingers, which is fine. And the kids that are sitting there going, I can't do it that fast. Or the kids that are sitting there saying, wait a second, how did you know that? And so think about how one of the strategies for eliciting this kind of differentiation is as simple as give them the damn answer. And so I simply say, hey, 8 plus 9, wait, I don't want you to say a thing. I'm going to spoil this. It's 17. Oh, wait, yeah. Well, you know what? You just ask Alexa. You just ask Google. You ask the tools of the trade. Everybody knows that 8 plus 9 is 17, one way or the other. So what's the question? The question is, convince me that it's 17. Talk to your partner. Say that out. This is one more time what I think we mean by less is more. I think we're talking about what strategies can we apply to 8 plus 9 that work for a whole lot of other facts and reduce the memorization load and focus on the different strategies. What an amazing class when, so 8 plus 9. Oh, I just know it's 17. I go, how'd you know? What'd your brain do? My brain just said 8, 9, 17. I don't know. I just know it. I don't believe any kid that says that. But you know how real that is. You know that when in first and particularly second grade and in third grade, we have kids saying, I hate 9. I make it a 10. So I just sort of, recognize that 8 and 1 more is 17. No, wait a second. I don't think it that way. I know that I can compensate, and I see this balancing act. And so I take 1 away from the 8, I add 1 to the 9, I have 7 and 10. There are so many ways of thinking about how I can compensate, or I can decompose the 8 into 7 and 1, right? How is your brain working on it? I sit there and say, wait a second, it's 18 minus 1. Where'd that come from? Well, I add 10. Why would I ever add 9? I hate 9s. 8 and 10 is 18 minus the 1, bingo. Wait a second, you're sitting there going, but don't you just do the double plus 1? Well, of course I do the double plus 1, knowing that some kids that's easy, other kids are weird and they'd rather do the double minus 1. Or they sit there and go, wait a second, you know those tens frames? I love those tens frames. And I know 8 is a whole frame minus 2, and 9 is a whole frame minus 1. I love it when a second grader says to me, 8 and 9 is 17 because it's 20 minus 3. I go, what, where, how? And they explain it, and the other kids are going, that's amazing. I'm changing the culture of a classroom when I understand I can differentiate, I can accommodate the fact that there are brains processing the math in different ways, seeing the math in different ways. Who's right? They're all right. Of course that. They're all right. Does it matter? And I think that the case that we need to make is it doesn't matter. Anyone that thinks that only the kid that knows it cold is the smart one and the one that's gifted is crazy. You know that these different strategies are what builds an understanding of number and of math and all those ways. And so again, it's building a classroom where we are regularly eliciting those things. So we differentiate by doing things in more than one way. There you go. One way. Boys and girls, you're in luck. Sarah has 91 empty boxes. She has 2,605 apples. That's ridiculous. I don't know how to put the pack into the boxes. How many apples will Sarah put in each box? Done, finished, good. I want you to laugh. I want you to stop and say, oh, I did that with kids 2 days ago. Oh my goodness. I mean, something equivalent to that. I put it all right out there, right? And notice, right? I just block the numbers out if I am in the top third. And I sit there and go, well, one big and one small. You wouldn't subtract them. You wouldn't multiply them. I guess you just, oh no, wait, I have the in each keyword. And so I sit there and use no understanding, no visualization. I simply use silly rules and I divide the 2,605 by 91 and I get some answer and then there's a remainder and I don't know what the hell to do with the remainder, but it doesn't make any difference because I'm going to have now a focus on the right answer and an opportunity to then do 7 more word problems. And I think that we need to get mad about this. I mean, in other presentations, I've talked about the fact that, right, when we see that and we don't say anything, I think that you know that we're complicit. We're complicit in allowing school to undermine kids. And so the question here is, where do we bring in differentiation? How do we use the power of our questions? And how do we do word problems like this so that, like in even Engage New York, that full page of the application problem done out over the full page, which tends never to sound like what my kids sound like, but regardless, at least they spend the time on it, but then they go to 8 stupid, mindless word problems to just go practice. Here's the alternative. A less is more, differentiated approach driven by our questions. And so I don't do any of this. I walk in and I say to the kids, read to me. Let's go, all of us. Sarah, and every kid screams out, has 91 empty boxes. How nice. You think I can remember what question to ask? No, I want kids to see it and hear it. I want to always be getting at through their ears into their brains and through their eyes into their brains. I know some kids don't need to hear it, other kids don't need to see it, but I want to know that in every class, I am accommodating all kids. Good. And so I smile and I give all kids access. I create a low floor. I have all kids thinking about Sarah, not just the numbers, but there's this human being sitting there with 91 empty boxes. What can you infer about Sarah? And then I just go, think for 30 seconds. By now, this is the 5th time I've done this already in this school year. And so the kids know that there are no wrong answers if they can justify it. They know that we all love the funniest answers. And so they got Sarah moving. And I go, Sarah's moving? It doesn't say that. Yeah, but why else would she have empty boxes? Oh, nice. So she might be moving. That's brilliant. That is called an inference. Well, we know that. That's what we do in language arts. We never understood why we don't do inferential reasoning in math, because that's where it needs to be as well. Oh, actually, Sarah's already packed 9 boxes. Where the hell does a 5th grader know that she's packed 9 boxes? And you sit there and go, well, we know how. I mean, she packed 9 boxes because no one orders 91 boxes. All you've got is just, the 91 boxes, and it's going to be, you ordered 100 and there are 9 boxes that are packed. How nice. Good. Sarah is a hoarder. I mean, what else would she be doing with all those boxes? Well, I got good news for you guys. She had 2,000. Notice I don't even change the Engage New York problem where this came from. Okay, I did this with a group of teachers 4 years ago when we were working in New Orleans, and we were playing off of how do we make the Engage New York work for all kids. She had 2,605 apples to pack in the boxes. In other words, we are animating. We are differentiating by hard returns in here. And now we ask, now what can you say about Sarah? And I shut up. My weakest kid tells us that she's working on her grandparents' apple orchard. my weakest kid says she's obsessive compulsive. Why would you say that? Because only a moron would count, or someone who is mentally ill is going to count 2,605 apples. And we're laughing and we're talking about that's really not funny, but you know what? No one counts it. And this is a stupid problem. And then, well, wonderful. So now we know about this stuff. I think that you know that we empower kids. We ask kids, what do you think the question is? I mean, all of the ways in which people are doing this work, and Brian Bouchard's amazing work on this, right? What do you think the question is? Why would I tell them how many boxes? Why would I do that when, well, what do you know? Will she be able to put the same number in? Will there be some left over? Are perfectly legitimate questions on this point. And I love it when they write them on their whiteboards and we have a whole list of questions. And there you go. Because what good is it if every kid can't tell you that the 91 is a factor, that 91 is the number of groups, and that the 2,605 is not the number in each group, but it's the total number. And if I have factor product, if I have part whole, I mean, I'm playing off of this critical understanding of what's going on with multiplication and with division, with two factors and with a product and all of those things. Great. And then I always throw in an estimation because, we never do enough estimation. Look at what I mean by spending 15 minutes on this problem and milking it for inferential skills. What do you think the question could be? What do the numbers mean? What's a reasonable estimate? I spend time on more than 100, less than 100. How did you do it? How did you do it? Does that make sense? I love it when kids say, oh yeah, more than 100. And the other kid says, well, if it was 100 times 90 boxes, that's 9,000 apples. That couldn't work. Oh yeah, right. So maybe it's a quarter of that. Where did the quarter come from, right? Convince us. And then the kid says, oh, that was foolish. I know what to do now. And then you all know those two questions make all the difference in the world. You all know that I'm differentiating when I have a recognition that some kids draw a number, create a number sentence immediately. They sit there and go, 2,605 divided by 91 equal box. And I say, draw a picture. And they go, I don't know how to do that. I have parents going, why did my kid have to draw a picture? Because we have two parts of our brain, because we have to be able to picture it and we have to be able to mathematize it. And you all know how many kids will never be able to come up with that number sentence until they are able to draw a picture of some sort. So look at how many birds I'm killing with this one problem. Why did you divide, not multiply? And that should be then, why did you multiply and not divide? I want to see that I could do both because they're inverse and I could do either one. And then finally, so, and there it is. Not how many apples. It's not blueberry. I mean, it is like blueberries. It wouldn't be the same number. About how many apples would be in each box if each box had about the same number. I think that process of animating, that process of our questions driving the differentiation is what we're talking about. And finally, think about who you were taught. And so let me just wind this up with, there's straight out of Singapore math. CD picks her clothes, packs her clothes into a suitcase, and it weighs 29 kilograms. And you just watch the air get sucked out of kids' lungs and brains. Raheem packs his clothes into an identical suitcase, and it only weighs 11 kilograms. CD's clothes are 3 times as heavy as Raheem's. This is obviously an SAT problem. Oh, this is obviously an algebra problem. Oh, wait a second. This is obviously a systems equation problem. This is now done in 8th grade. I got some relationship between CD and Raheem's, and then I have these ridiculous questions about the mass of Raheem's clothes, Singapore math, the mass of the suitcase. And already, you should be thinking about hard returns and animated lines. You should be thinking about a slew of questions to give them a reason to care. You should be providing differentiated opportunities for access. And all I want to do is I want to remind you that this is the way in which math is taught. No, that's not how it's done, right? We sit there and follow the alien memorized rules of set up your variables. This is algebra. It says it over on the side of the wall. How do you solve a problem? You set up your variables. Well, there they are. You then use the relationships in the word problem to create equations about your variables. Oh, thrilling. You know what? That's not all that hard for most kids, but as you well know, what the hell do I do now? Oh, I substitute, sure. The kids say, substitute what? Well, if S equals 3R, goodbye S, hello 3R. And so the S equals 3R on the left gets put into 3R for S in the middle, which then becomes 3R plus X equals 29. Big deal. Oh, no, but then I can subtract because I get two equations with r and x, and then I get 2r equal 18, and I'm lost. I divide by r, I get the thing, and all I want to do is just finish this up by saying to you, wait a second, I don't know anything about cities closed or Rahim's closed, except cities closed at 3 times Rahim's. City, green, 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 Rahim, green. What's the purple? Oh my God, that must be the suitcase. Oh, so I got Rahim, 1/3 of cities 3 times Rahim's. I got the suitcase, I got the 11, good. What's equal to 11? It's go to that top row. What about the top row? Well, it's Rahim. What about Rahim? Rahim's clothes and suitcase are 11. Well, what happens about the bottom row? Oh my goodness, that's Sidi, the 2 on the right. And you all sit there and see the right-hand green and the purple, that's 11. How much is left for the other 2 greens? Go back. That's why I subtract. I subtract because I'm getting rid of that green and purple, that 11, so I'm left with 18 for the 2 greens, which each one is 9. And now I go, I've got 9 and 2 on the top, 9, 9, and 9. I'll be damned, I'm done. I've solved the problem. Everything I need to know is right there. No, wait. I can now put clothes and suitcase into this. I can now sit there and create an equation, but the equation comes out of the picture. Again, multiple representations. And all I can tell you is that as it gets to 401, all I can tell you is that I listened in Vermont 4 weeks ago about, well, remember, you can use a table or you can use a graph or you can use the symbols, and all that was on the board was symbols. And so I did, for the first time in a year and a half in a real class with real kids, I went over onto the other board and I drew a table with only 1 entry, and I drew a graph with 2 points. And then I sat down. Those are the risks we all take. That's why I want to be coached. That's why I love coaching. And in this case, the teacher goes, oh yeah, I should have done that. I'm talking about them and I'm not showing you. And all of a sudden, the kids are going, oh yeah, I could have started with the table. Oh yeah, I could have started with the graph. And lo and behold, I solved the problem. Just look at what we accomplished, my friends, and what we can accomplish by consistently turning to and following up on those wonderful 2 questions. There they are. Put them on the wall. Tell the kids they get extra credit if they point to the question when you forgot to ask those questions. Recognize that it is worth taking longer to empower kids with these ideas that undergird differentiation. What an absolute pleasure. TJ and the whole rest of the ALN crew, thank you for having me. This was a pleasure. Thank you, everyone.
Thank you so much, Steve.